Hello, this is my physics lab presentation. The purpose of this lab is to observe the change in position of an object compared to the time of an object with constant velocity, and use its observations to simulate the object's motion in Python. The main principle at play is Newton's second law, which states that an object's acceleration is determined by the net force acting on its mass. The final result showed the variation between the predicted and observed positions due to errors. My original video and models. The tech deck was pushed across the screen and tracked. The tech deck is assumed to have a constant velocity. The tech deck is in our system, and the floor and the surrounding areas are its surroundings. And the tech deck starts at position 15.12 and the velocity about 608.87 units a second. And we calculated that with the equation as seen here, which is the final position minus the initial position divided by the final time versus minus the initial position. And this is the experimental data that was taken after I first tracked the tech deck with the tracker, and then from there I uploaded its I calculated it, and then posted. From there I calculated the time, which it can be seen here, the time, and then this is the final time, this initial and then the final time, and this is its average velocity divided by 100 because it's taking it at 0.0 time state, and then this is the ball's position vector at 0, 0. And if we run this, we get this line, which is the predicted amount according to the velocity, and we have all of the velocity, the time, and position points here. If we go back to the data, we can see the time, which lines up, and then the observed position, which is these, what we got from the tracker. The predicted position is what we got from Python, and we can see the two graphs here. The blue is the observed and the red is the predicted. Some sources of error, as we can see in the previous on the graph, that the blue line is sometimes curving up and down, is because the tech deck, assuming that the tech deck had a constant velocity, which is not true because it was pushed and the amount of force could have increased and decreased. The tracker was not able to perfectly track it at every single frame because of blurry frames, and the errors caused a fluctuation of the slope, and observed position of the tech deck was not seen in the predicted positions. And for the questions, what if the axis were flipped? If the axis were flipped, then the velocity would just be in a negative direction since it was moving across the screen. And how many forces are acting? The main forces were my finger, and the force of friction was pushing against it, the normal force and the force of gravity, and also resistance from the air molecules. Thank you.